हेलो गाइस, तो आज हम स्टार्ट करते हैं एक नई वीडियो जिसमें हम अपने चैनल का फर्स्ट कंपटीशन देखेंगे विच इज़ अ प्लेग्राउंड प्रिडिक्शन कंपटीशन फ्रॉम ऑन कैगल। तो दिस इज़ अबाउट प्रिडिक्टिंग पॉडकास्ट लिसनिंग टाइम। सो हमें इसमें क्या है कि एक डेटा सेट दिया हुआ है और उस पॉडकास्ट के रिलेटेड डिफरेंट एट्रीब्यूट्स दिए हुए हैं और हमें प्रिडिक्ट करना है कि यूजर उस पॉडकास्ट को कितने देर तक सुनेगा। तो ये ही इस कंपटीशन में है। प्लेग्राउंड सीरीज बेसिकली क्लासिफिकेशन और रिग्रेशन टाइप्स के प्रॉब्लम के ऊपर होता है। बिगिनर टेबुलर टेबुलर डेटा सेट्स पे बेसिकली होता है। इसमें हमारा इवेल्युएशन मेट्रिक है रूट मीन स्क्वायर एरर, और सबमिशन फाइल में हमें प्रिडिक्ट करना है लिसनिंग टाइम मिनट्स। ठीक है, तो एक महीने तक चलता है कंपटीशन। टुमारो इट विल बी द लास्ट डेट फॉर दिस कंपटीशन। सो लेट्स गो टू द डेटा सेक्शन। डेटा देखते हैं हम। आप यहाँ पे आपको यहाँ आएगा ज्वाइन कंपटीशन का, अगर आपने नहीं किया ज्वाइन तो। सो दिस इज द डेटा सेट. This is the training data set which has been provided. It has multiple columns, like 12 columns I can see: podcast name, episode time, title, episode length minute, कितने मिनट्स का है, जॉनर क्या है उसका, होस्ट पॉपुलैरिटी, पब्लिकेशन डे। ये सब हम कोड में देखते हैं, ज़्यादा बेहतर समझ जाएगा। तो एक नई नोटबुक बना लेते हैं यहाँ से। ये वाला सेक्शन तो सबको पता ही है, डिस्कशन है कि आपको कुछ भी डाउट है डेटा सेट वगैरह से रिलेटेड तो यहाँ पूछ लो। लीडर बोर्ड है, मैंने भी सबमिशन किया है तो देखो मेरी रैंकिंग दिखा रही है यहाँ पे 1000 के कुछ। तो लेट्स ट्राई टू रिक्रिएट दिस रिजल्ट और हम एक नोटबुक बना लेते हैं। यहाँ से नोटबुक बनाने का ये फायदा होता है कि इनपुट अपने आप आएगा यहाँ पे। जो भी कंपटीशन का डेटा सेट है वो हमारे पास पहले से ही आ जाएगा। ठीक है, तो लेट्स डू सम इंपोर्ट्स फर्स्ट और हमारा नोटबुक भी स्टार्ट कर लेते हैं। इसको नाम देते हैं प्रिडिक्ट पॉडकास्ट लिसनिंग टाइम। ठीक है, सेशन स्टार्ट होने दो। ठीक है, सेशन स्टार्ट हो गया है और इंपोर्ट्स हमने कर ही लिए हैं। फर्स्ट 5 रोज देखते हैं डेटा सेट को लोड करके, बेटर समझ में आएगा। पॉडकास्ट नेम जैसे देख सकते हो, मिस्ट्री मैटर्स। एपिसोड टाइटल गिवन है, एपिसोड लेंथ मिनट्स। यहाँ हम देख सकते हैं कि पहले ही नल वैल्यूज दिखाई दे रही हैं। तो we will see null value analysis we will done, because we will have to impute the null values so that we can train some model on it. फिर जॉनर है कि डिफरेंट जॉनर्स जिसके ऊपर वो पॉडकास्ट है। बेसिकली होस्ट पॉपुलैरिटी परसेंटेज, ये पॉपुलैरिटी है कि होस्ट की क्या पॉपुलैरिटी है और गेस्ट की क्या पॉपुलैरिटी है। इन दोनों के बेसिस पे हमें दो कॉलम्स दिए हुए हैं। पब्लिकेशन डे है और पब्लिकेशन टाइम है, और यहाँ पे नंबर ऑफ एड्स पॉडकास्ट के बीच में कितने ऐड आएंगे। आई गेस दिस इज व्हाट इट इज अबाउट। एपिसोड सेंटिमेंट, पॉजिटिव, नेगेटिव, न्यूट्रल, ये तीन चीजें दिख रही हैं। और दिस इज आवर target column which we will have to predict. So we can understand this, that we have a continuous values to be predicted. So we will use regression models to predict this listening time minutes. But before that, let's do some data analysis. This ID column is nothing but the same, I guess. So we will remove this and check. So we have around 750,000 rows and 11 columns. And if I check info, here I can see there are some null values in episode length minutes, guest popularity percentage, and number of ads. So okay, the rest some I have object columns float 64, यानी कि continuous values I have. So here I can see some of the statistics of the numerical columns. And let's first check the null values. So here I can see the exact count of null value columns in the dataset. One thing we can do is simply remove all the null values and make do the prediction. Or we can also do this. We remove the episode length minutes. We remove the guest popularity percentage, these two columns from the dataset, because only these two have null values. So if we remove this, our null value problem will be automatically sorted. But we will not do that because it will lead to loss of so many data. So we will do null value imputation. Okay. तो क्या अप्रोच लगाएंगे हम? सबसे पहले एक चीज मैं करना चाहता हूँ बिफोर वी डू एनीथिंग। आई वांट टू ऐड one column that is episode length minutes is null. So this column will denote or describe which uh, which rows had null value in the starting. So it will be a mark or flag which will tell me whether initially this value was null or not. Okay, so this is about that. और फिर हम क्या करते हैं, देखो व्हाट आई वांट टू डू इज, ये मैंने अप्रोच इसमें लगाई थी नल वैल्यू इम्पुटेशन के लिए कि फॉर अ पर्टिकुलर पॉडकास्ट विद अ सर्टेन एपिसोड टाइटल एंड पब्लिकेशन डे एंड पब्लिकेशन टाइम, अगर इसके बेसिस पे हम फिल्टर करें रोज को तो क्या आएगा। तो एक मैंने ये ले लिया है, ये फनी फोक्स वाला कुछ है। लेट्स टेक दिस वन एग्जांपल। इसका एपिसोड है 98 and this was published on Thursday in the night time. So here I can see that there are three such episodes in the podcast Mystery Matters. Genre is true crime for each one of these. Publication day and publication time is same. तो बेसिकली इसमें मेरी अप्रोच क्या थी कि तो एक पर्टिकुलर डे में एक पर्टिकुलर टाइम के लिए टाइम पे जो भी पॉडकास्ट रिलीज होते हैं जनरली उनका टाइम ड्यूरेशन सिमिलर ही होता है। तो उस बेसिस पे मैंने ये अप्रोच लगाई थी, ऑल्दो यहाँ पे डिफरेंस है काफ़ी ज़्यादा 20 and 50, बट व्हाट एल्स वी कैन डू बिकॉज जो भी we cannot do directly find the average value and fill all of them by that. So it will be quite naive approach and not a good one, good method to make the imputations. So this approach I am using. So using this I have written this for loop. इस वाले कोड को समझते हैं थोड़ा। What I have done is I am first fetching all the rows which have null value in the episode length minutes. Okay, episode length minutes. So what I'm doing is trying to fill this column because uh, episode length minutes matter too much for the listening time minutes. So what I'm doing is recognizing if it is basically null value or not. If it is not a null value, not I am using, then I will continue. Otherwise, I will fetch that row, perform this filtering to find the temp, and based using this temp I am filling this one and this one by null values, by average basically. So I was using this approach to fill the rows, but what happened is so in this code what I am trying to do is I am doing the filtering which I have shown here using this code, and I'm using these values average to fill this one. This is what is being done by this much of code. So what I have to do is I have to follow the same approach for the guest popularity percentage. There should be two different loops basically, like this it should be. Here one loop for the episode length minutes and one for the guest popularity percentage, because there are chances for uh, that there must be those their episode length minutes does not have a null value but guest popularity percentage have. So in that cases we have to deal with it separately, but using this for loop approach is very time consuming. So I use ChatGPT to help me in this situation, and this is the code which I got to fill the null values by ChatGPT. What it does is it does not use for loop explicitly, and it does group by using all the columns which I want to use during the group by thing, which are basically these columns: podcast name, genre, episode title, publication day, and publication time. So these are the columns which I want to use. But even after using them, there can be a situation when all these three are null. Then what can I do? So I have done exhaustive filtering here. If I remove this one, or if I remove the publication day or publication time, Then maybe I get some rows with non-null values and I can use that to fill the null values. So I have to run this with different combination of this group columns. So for that, I am using a for loop here. Uh, for loop, no, basically a while loop I am using. See this code, try to understand. In this code, what I am doing is if data frame has null values still, then what I want to do is do this grouping and fill the null values and pop the last element from the group columns. Like first publication time will be dropped, then publication day will be dropped, then episode title, then genre, then podcast name. But there can be chances that still we have null values in the data frame, but group columns has been exhausted or all the elements has been popped out. So we will break this loop and we will do this. Now this is basically complete naive approach because what I am doing here is simply filling the average value here. So what one thing we can do is we can create a data frame for this, not data frame, basically a function I would like to create, fill NA columns for my past data frame. And it will return me a data frame with all the null values being imputed. So let's use this to fill all the null values and let's check now how many null values are still there in my data frame. So there are no null values. So this is how we can impute the null values in this situation. But there is one caveat here that I would like to show, which is that ideally episode length minute should be greater than or equal to listening time minutes because you cannot listen a podcast which is 10 minutes for 20 minutes. Okay, which is of length 20, 10 minutes, but you are listening it for 20 minutes. You can do it in loop, but listening time minute should be ideally less than episode length minutes. So if I try to check this condition here, that which are the rows in which episode length minute is shorter than listening time minute, because this is a flaw and there are 23,000 such rows where this condition is not getting satisfied. So the cause of this may be because we have done imputation using the average value and which is not a good way, but ये ही सबसे suitable मुझे तो तरीका लगा. There must be other ways also. You can read some other notebooks in the competition or the code section of the competition. But as of now, I am moving forward with this much only. Okay, so हाँ, I told you like I am adding these two columns. तो ये भी हो सकता है कि जहाँ पे भी null values हैं and I will have a one there as a flag. Okay, because is null will give me true where there was a null value. So when a regression model will be fitted, then this will help me rectify this mistake, this one. So it will give a idea to my model, like yeah, these are the rows in which there can be some problem with this relation between the two columns. तो ये हो गया हमारा null value imputation. Now we can move forward with the data analysis part. Okay, so we will perform some EDA. First, let's explore the number of ads. So here I can see 0, 1, 2, 3, and there are some values which are way too high. So I will remove these rows with so many ads because it seems like some mistake only. Okay, so let's remove these value by flipping it to less than 10 ads. So only I will have these four type of number of ads, 0, 1, 2, and 3. Okay, so now let's do some analysis on the categorical columns. I have like 6 categorical columns. Some have more than 10 unique values and some have less than 10. So we can create Okay, we can do one thing. We can apply some group by to identify uh, what is the distribution among different, values in the data set. So जॉनर में देख सकते हो कि करीब करीब स्पोर्ट्स के लिए बहुत ज़्यादा पॉडकास्ट दिए हुए हैं एज कम्पेयर टू एजुकेशन। संडे को जनरली ज़्यादा पॉडकास्ट रिलीज होते हैं विच इज़ क्वाइट ऑब्वियस। नाइट टाइम पे ज़्यादा है एज कम्पेयर टू मॉर्निंग, बट इतना डिफरेंस है नहीं यहाँ पे डिस्ट्रीब्यूशन में। 20,000 का है बेसिकली। यहाँ पे एपिसोड सेंटिमेंट ये तो अप्रोक्सीमेटली इक्वल डिस्ट्रीब्यूशन ही है ऑल द थ्री कैटेगरीज में। फिर पॉडकास्ट नेम है जिसमें से टेक टॉक्स में सबसे ज़्यादा पॉडकास्ट होते हैं और न्यूज़ राउंड अप में सबसे कम होते हैं आई गेस, विच इज़ शोन बाय द डेटा सेट ओनली। और अब हम देखते हैं न्यूमेरिकल कॉलम्स के बारे में थोड़ा सा। ठीक है। अ, यहाँ पे हम ये भी कह सकते हैं कि एक आध पाई चार्ट बना के देख सकते हैं लाइक publication time और episode sentiment के ऊपर। तो you can see that there is approximately equally distribution in all the unique values in each column. Okay, so this is the code for that. Let's create some distribution plots for our numerical columns. Okay, this will help us analyze the distribution of these values. We generally prefer normal distribution of the continuous values in the data set. देखते हैं किस किस में कंटिन्यूस है और किस में नहीं है। एक बार हमारे ये चार्ट्स बन जाए तो यहाँ मैं देख सकता हूँ कि जनरली तो नॉर्मल डिस्ट्रीब्यूशन ही है एक्सेप्ट नंबर ऑफ एड्स। यहाँ पे 0 1 2 3 तीन ही वैल्यूज हैं, बट एपिसोड लेंथ मिनट में आई गेस देर आर सम आउटलायर्स। Let's check for those outliers. It is after 100 only. So I will check after 120. How many rows are there? So only 9 values. If I clip the episode length minutes to less than 120. So I will do that because it will help me make my this column to be normally distributed as well. ठीक है, तो this is the time। और भी हम फर्दर एक्सप्लोर कर सकते हैं डेटा सेट को, बट इस वीडियो के लिए हम इतना ही करेंगे। आप और नोटबुक पढ़ सकते हैं दूसरों की, इट विल गिव यू बेटर आइडिया। ओके, इसमें डेटा प्रोसेसिंग का क्या पार्ट है? न्यूमेरिकल कॉलम्स तो है ही हमारे पास, बट वी विल क्रिएट सम वन हॉट encoded columns as well as ordinally encoded columns because we cannot have like 100 different columns for this podcast. Here we have seen, where is that? This one. So we can create a one hot column for these three features. But for these three, I guess we will have to move on with the ordinally encoded only because it will, if we create one hot for all the categorical columns, it will create so many features that we will have to deal with the curse of dimensionality, which is about after a certain point of number of columns in the data set, uh, the accuracy decreases only and not increase anymore. So we will not have that many columns, but we will move on with these three: journal, publication time, and episode sentiment. For these three columns, we will create one hot columns, df dot head. So these columns have been added to my dataset. Here you can see for each column, I am creating dummies. Then I am dropping that column and concatenating the dummies with the data frame. Okay. And finally, I have returned the data frame here. So this is about the one hot encoding. Now for ordinal encoding, we will create this a dictionary to number mapping for each this podcast name and podcast date for these two columns. And for episode title, you can see that we have number for each one. So if we remove episode and space, so it will be already in the numerical format. So that's what I have done here. I have replaced episode with a nothing and convert this to integer. Here I have created that dictionary which will be used to map the dataset to the publication date. Okay, to convert it to nominal encoding. So finally, I have all the features in the number format and it is ready to be fitted in the regression model. Any model we can use, we will see that. First, create a heat map. And here I have done this greater than zero point 0.8 to determine which columns are highly correlated. So here I can see listening time minutes is really correlated with the episode length minutes. This is quite obvious because if a certain episode is of 60 minutes, then you can watch it for 60 minutes. But if one is for 100 minutes, you can watch it for more than 60 minutes. So higher is the episode length minute, more is the tendency for a fan or someone who is listening to watch it till the end. So listening time minutes will be automatically high there. So this relation is not that prominent, or it may not cause data leakage to us. So we will move on with keeping this column in the dataset only. I have splitted it in the training and validation, and I am standard scaler. I have used standard scaler to normalize the dataset. Okay, so basically what I want to do is I will just fit the data on the XGBoost model, and you will have to use this Optuna code to look out for the best hyperparameters, which will give you even better results. So first, let's see this one only. For XGBoost, let's see how much accuracy we are getting on our dataset. Okay, so here you can see that 400%. What does that mean? So I told you in my last video that we have 4 cores in the Kaggle notebooks. Each one is working up to its full potential, so 100% each. So 400% we got computation there. Okay, so I am getting validation root mean square error around 13 and training is around 12. This is the code, Optina code I asked from the ChatGPT. Optina help you to uh, search or look for the hyperparameters in a region where you are getting better results or the error is decreasing in that region only. So Optina is used for the hyperparameter tuning. Once you run this, you will get um, best hyperparameter for this. You can, here I have used GPU histogram and GPU predictor. You can turn on one of the GPUs and then run this code. Otherwise, it will take a lot of time. So don't get into that. Don't use GPU or CPU. Use GPU for the hyperparameter tuning of this model. So I have fitted the model. Now it is the time I use this model to make the inference on the test data. Okay, so let's see. Let's break this code one by one. Okay, why I am doing this? The reason behind this is my testing data will also contain the null values. I would like to show this to you. Let's load the data set here and test dot is null dot sum. So if we check here in the same 2 columns, I again have the null values. Okay, so I will use the same approach I used earlier, but one thing you can note that more is the data, better will be the null value imputation. Because if this testing dataset contain around 2.5 lakh rows, but what if there was only one row with episode length minute and guest popularity percentage having null values? So how you will impute that? That's why I am using the training dataset also to fill the null values in the testing data. That's why I have loaded again my training dataset. I have added the 2 columns in both of these. So that is why I have loaded again the training dataset and add those two null value columns, basically flag, which I added in the starting of the null value imputation, because this will help in the testing also. And I am dropping the ID and listening time minutes from the training data, and testing data I am removing just the ID column. Then I am adding a label test and train in both of these because it will help me segregate the testing data later, because currently I am concatenating both testing and temp data. And then I have used my function fill NA columns, which will help me fill all the null values in the combined data frame here, which have testing and training raw data. Okay, so now we will segregate the testing data from the complete data frame, that is DFT. Uh, After segregation, I have removed the label from the testing data because it was not in the training data, right? So now it is the time. Before moving forward, I would like to remove these DFT and temp data frame because they are not required anymore. Then what I will do is perform the one hot encoding as well as the ordinal encoding for my these two columns, as well as I will remove the episode thing from the episode title to make it similar to the training dataset. Okay, so now we will load our submission file, sample submission.csv, and we will have these predictions using model.predict function. And we will do one thing before that we did with our training dataset. We did the normalization, right? So we will do that same thing here also with our testing data. Then we will add that to the sample submission data frame, and this is my final results. You can convert this to CSV file, name it submission.csv, comma index equal to false. Why this extra attribute? Because if you don't add this, you will have this ID column in the testing in the data frame, which will be created like this ID column you can see here. So similar to this ID column, you will get in the submission file, which will throw an error because submission file expect this ID and this listening minutes only. Okay, so we will make that happen like this, and we got our submission file here. Okay, now you can save version, click save, and we will do always save output, right? So I am saving this file here. Click save. One benefit we have directly the output input file and the current state of the notebook will be saved as it is instead of running all the cells again. So this is a really quick save method. So once it is saved, you can go here. Here you can see this option submit to competition. When you will click on this, you will get all of these things. Currently, I have the first version only, so version 1, and only one file also I have. So I can I can choose this one and submit. So once it is submitted, you will see a score for your submission here. This is public score. Once competition end, all the private data set is loaded in the testing data and your notebook is run again, need to run again. Okay. So I'm getting 13 score, which is not better than my last score. So on leaderboard, this is what I get. So this is how you can, okay, so I guess now you guys must have got an idea how to approach this competition and make a submission. You can apply more null value imputation, better technique, and add some more features to get better results. Best score on the leaderboard is of 11 RMSC, and we are getting 13. So there is a scope of improvement. Um, comment, you can comment your approach also if you are getting better results and this video helped you. So thank you so much. We will meet in the next video.